In 1983, a brand new Boeing 767 ran completely out of fuel at 41,000 feet over Canada, with 69 people aboard. The aircraft was registration CGAUN, a gleaming Air Canada jet that had been flying for less than a year. Every single engine went silent, and the crew had no manual, no precedent, and no power to guide them down. What they did next should not have worked, but somehow it did. And the reason why still haunts aviation engineers today. At cruising altitude, a 767 weighs roughly 150 tons and is traveling close to 500 miles per hour. Without engines, that weight becomes a problem that physics solves in only one direction, straight down. The cockpit went dark in stages, instruments flickering out one by one as the electrical system starved and died. Captain Robert Pearson had maybe 20 minutes before the ground made the decision for him. A commercial airliner is not a glider. It was never designed to be one, never tested as one, and no airline crew had ever been trained to fly one unpowered from that altitude. The 767 had been in service for less than 12 months, so there was no crash history, no survivor account, nothing to borrow from. 69 lives were now riding on a question that aviation had never had to answer before. How far can a dead jet actually fall before it's truly lost? That silence didn't come from mechanical failure or a hidden flaw buried deep inside the aircraft. It came from a number. A single, wrong number entered by a ground crew in Montreal that morning. The 767 was one of the first commercial jets to use a digital fuel quantity system, and that system was broken. With the gauges offline, mechanics calculated the fuel load the old-fashioned way, manually, using a dripstick and a conversion factor. The problem was they converted liters into pounds instead of kilograms, and those are not the same unit. Jet fuel weighs roughly 1.77 pounds per liter, but only 0.8 kilograms, so the plane left Montreal carrying less than half the fuel it needed. Nobody caught it at the gate, nobody caught it during the pre-flight checks, and nobody caught it at altitude until both engines simply stopped. A brand new Boeing 767 had been turned into a glider by a math error that a schoolchild could have spotted. And now, with 61 passengers aboard and no power at all, the crew had seconds to decide what came next. Captain Bob Pearson had flown gliders as a hobby, and that obscure skill was about to save 61 lives. He and First Officer Maurice Quintal were nursing a dead Boeing 767 toward a decommissioned airstrip near Gimli, Manitoba. The strip had been a Royal Canadian Air Force base, then a drag strip, and on this particular evening, it was hosting a live race event. Quintal punched the coordinates into the flight computer and confirmed the runway was long enough. Barely. What neither of them knew yet was that the runway was blocked, with cars, spectators, and barriers spread across the tarmac below. Pearson set up a steep, aggressive descent, bleeding off altitude the way only a pilot who understood unpowered flight could manage. He had no engine thrust, no hydraulic assist, and exactly one shot at this approach. The nose gear refused to lock. It dropped but never clicked into position, leaving the front of the aircraft on a razor's edge. Pearson greased the mains onto the runway, and the unlocked nose gear collapsed immediately, grinding the cockpit forward into the asphalt. The aircraft stopped. The fire that everyone expected never came. 61 people walked away from a runway that should have been their grave. The 767 that landed at Gimli didn't just survive. It rewrote what aviation engineers thought they knew about unpowered flight. Before that night, no one had seriously modeled a fully loaded wide-body jet gliding 60 miles without a single engine running. The numbers that came back from the incident data were startling. A Boeing 767 at altitude carried enough energy to travel roughly 12 miles for every mile it descends, far better than anyone had formally documented. That ratio became a design benchmark, quietly folded into emergency procedures for every wide-body aircraft that followed. Aviation regulators also tightened unit conversion requirements across the entire industry, mandating redundant checks wherever metric and imperial systems touched the same fuel calculation. The crew's paper logbook math, the kind of fix no engineer had ever trained for, became a case study in improvised problem-solving that's still taught today. What haunts engineers isn't that the system failed. It's that a $2 arithmetic mistake nearly killed 61 people on a brand new jet. And the only thing that saved them was a glide ratio nobody had bothered to measure. Every flight has a story. Every investigation leaves a lesson. And sometimes, the most extraordinary mysteries are hidden in plain sight. Until our next journey into the extraordinary, keep looking beyond the obvious, because the world is full of ordinary unknowns. If you like our content, support and subscribe to our channel.